I hear that's yeah, that's static.
Okay. I think we are okay. Um, Good. I will also mute myself, of course, once we are starting the presentation. Okay, welcome everybody to the ICSE session, second session on human aspects of software engineering. And we have a nice set of presenters here, a nice panel of presenters. So for everybody in the audience, welcome to this panel, and I hope that we have interesting. I'm sure we have interesting presentations. I hope we have an interesting discussion afterwards now. So the first person presenter here is Dine Ford from. I think you're from Microsoft. Please correct me if that's not right. And she will present a tale of two cities, software developers working from home during pandemic. So welcome, and yeah, please start your presentation.
Excellent. Let me go ahead and unmute myself so you guys can actually hear me speak. And hopefully you all can still see my screen. Audio confirmation would be great because I can't see you
Yes,
all.
yes.
Okay. Awesome. Thank you. Thank you so much, Yvonne. And you all have to forgive me a little bit. I am suffering from a few COVID symptoms, so my voice is a little bit more faint today. But thank you for the introduction. I'm Danae Ford from Microsoft Research, and I'm going to talk to you all about a very timely topic where a few of us researchers at Microsoft Research Academia as well, like Peggy and as well as other organizations, have been really investigating how to support developers during the COVID-19 pandemic. And I'll talk a little bit about the timeline that we studied in, which was in the early 2020s, so the early stages of the pandemic. You all may be very familiar with this quote. It was the best of times. It was the worst of times. It was the age of wisdom. It was the age of foolishness. It was the epoch of belief, the epoch of incredulity, the season of light and the season of darkness, the spring of hope, but it was also the winter of despair. And this is a quote from Charles Dickens, and I wanted to start with this because I think it's really important that we drive home the fact that the pandemic, which is still ongoing, uh, has had a lot of advantages and disadvantages to folks, and I'll talk a lot about that. But pre-COVID remote work, software developers and a lot of large software organizations like Stack Overflow, GitHub, and GitLab have been working remotely quite often. So even from this American Community Survey, from of all the different types of working dimensions, software development, computer science fields, we're already working increasingly remotely. This is between like 2017 and before. Um, in fact, Alexander and myself actually studied, and some other folks in 2017, investigating the advantages of remote work and how in these settings you can have more autonomy over your identity and even flexibility on how you want to work and re-engage in the workplace. However, we wanted to see if these advantages or disadvantages, we want to see if they still hold during the pandemic, because we know remote work is not quite the same as pandemic remote work. So we investigated 4 core questions. I only have time to really show briefly 3, where we wanted to understand the productivity changes in developers, the benefits they may be experiencing, the challenges, and even insights on some of the recommendations. Our timeline took place, I mentioned, early 2020 in the United States, and we're based in King County, Washington, in the United States on the West Coast. Everyone was asked to go remote work in March of 2020. So March 5th is when we started working from home officially from Microsoft. And that's when we launched the survey. So we started collecting questions about all the things I mentioned before, the advantages and disadvantages, and conducted this open coding analysis, identifying 6 core themes around how people were working remotely. We also conducted a secondary survey where we understand a little bit more at scale, quantitatively, what were some of the changes in that benefits and challenges and how that impacted productivity as well. So now for a little quick dive into our findings. Along the productivity changes, we actually saw that compared to working in office, a lot of respondents identified that their productivity was quite the same, right? So you see there's quite this split of who was more productive, who was less productive, and who didn't see a change. So that's also kind of driving the title that we have here, which is the Tale of Two Cities, this dichotomy of experiences. On the next few slides, you'll see that I'll point out some of the benefits that were also some of the similar challenges. So one I'll call out here is the schedule flexibility, where many developers, program managers as well, were saying that they now had control over their own schedule and how they worked. They weren't constrained by a clock. Um, and it also presented unique advantages when they were trying to be more productive, where they spent less time on commute, and likewise had a better work-life balance. Um, On the challenges side, you can see that there's also some of the similar advantages, but again, I mentioned quite the opposite, where although they may have had more schedule flexibility at home, folks also felt like there was a little bit more of a confusion blur of work and life, and how that was going to manifest itself in how they worked later on, maybe even impacting things later on like burnout, as we saw in other accounts of the pandemic. We also saw that from the challenges, there were significant challenges around missing social interactions, how teams were collaborating. Again, that lack of work-life boundary. We saw that this missing social interaction came in a second study, how important it was when people and teams were trying to build relationships amongst one another, especially challenging for new folks onboarding to development teams. So as I close, I wanted to again drive this home, this point of this yin and yang of remote work. We saw some interesting. I have the taxonomy here of our of the themes we identified from our first round of our survey. One thing that's not really highlighted as often or doesn't get talked about as much is these challenges of childcare needs. So we wanted to make sure we highlighted that in this work, and I'm also happy to talk more about that after this session because I know we have a slew of speakers. As I'm closing right now, I do want to also point you all to the follow-up studies I mentioned, but also Microsoft recently released their new Future of Work report, as in like last week. So I advise you all to check that out. And there's amazing recommendations that build upon some of our initial recommendations from March of 2020, and different ways to think about what hybrid work looks like for teams. So thank you.
Thank you very much, Sinead. That was impressive, very impressive. Yes, next is, next is Nicole, and she's talking about emotions and perceived productivity of software developers at the workplace. I'm sorry for the echo, but it suddenly came about.
Okay. Hi everyone. Thanks for the introduction. I hope you all can see my slides. Okay. So
yes.
I am. Okay. Thank you. Okay, I'm Nicole Novielli from the University of Bari, and I'm presenting today a joint work together with the Technical University of Eindhoven, and about the emotions and perceived productivity of software developers at the workplace. And this as a journal first paper that was originally published in the IEEE Transaction of Software Engineering. So emotions play a crucial role on people's everyday performance at work and in general in their life. And this is especially true for activities that require creativity and problem-solving skills, such as software development, for example. So according to previous work, for example, according to Graziotin and colleagues, happy software developers achieve better performance, while unhappiness brings developers to lose their motivation and eventually might even lead to leave the company. So we want to study the emotion of software developers as they are experienced and self-reported together with the self-assessed productivity at the workplace. So we run a field study and we try to address this research question. So first of all, what is the range of the emotions of developers at the workplace? And to what extent are these developers' emotions related to their self-assessed productivity during the workdays? And then we also investigated what are the triggers for developers' emotion at the workplace. And to address this question, we used data collected through self-report of emotion and self-assessed productivity. And then we also try to investigate whether we can predict developers' emotion at the workplace using lightweight biometric sensor, and we run a machine learning study using feature that we extracted from the raw signal collected using non-invasive biometrics. So the study protocol involved a duration of the study of 2 to 3 weeks, depending on the agile iteration cycle implemented at each company. Overall, 5 companies in the Netherlands were involved, and we had 21 developers participating to this study. Upon arrival, all developers wear the device, and they start the pop-up application that we developed in order to enable self-report of emotion, activities, and self-assessed productivity during the workday. And at the end of the day, the developer downloaded the Empatica E4 wristband data and shared this with the experimenter. Using a Dropbox folder. So here are some main highlights of the findings. And of course, if you want to check the paper, you will find more detail. So in general, as regards emotion and productivity, developers mostly experience positive emotion. They feel in control of the situation in terms of dominance, and they seems to be not very excited about what they're doing because they report like arousal. And in terms of productivity, they also report average or above average productivity, which can be seen probably as a consequence of the fact that they were mostly experienced developed with on average 8 years of experience. So they tend to be most of the time in positive mood, they feel in control, and they feel productive. And we also investigated the correlation between emotion and self-assessed productivity, and we found that balance is positively correlated with perceived productivity, and we observe a stronger correlation in an afternoon, which we probably explain in terms of fatigue, which is known to impair emotion regulation. So we have a stronger correlation in the later hour of the day. As for emotion trigger, we investigated the causes for emotion. So this is the pop-up application we use to collect self-reported emotion, and we also have a text field where people could explain why they were reporting such emotion. So we started by reading literature on triggers of emotion in software development, and we found 48 known triggers. And then through a series of manual coding iteration, we annotated the answer of the developers, and we come up with 18 positive emotion trigger and 19 causes for negative emotions. Positive emotions are mostly triggered by developers' perception of being productive, either because they feel in flow or they complete their task. Other cases are working code with no errors, constructive meeting, and successful collaboration with peers. And negative emotions are mostly triggered by code comprehension issues, by the feeling of being stuck or not being very productive, and also fatigue plays a role as well as personal problems. Then we have tried to address our fourth research question regarding sensor-based emotion recognition. We use the Empatica E4 wristband to collect galvanic skin response and health-related metrics, and we use the self-reported emotion in terms of positive, non-positive, as collected during the experience sampling during the study. So we run a machine learning study, and here are the main results. So our classifier consistently outperformed the majority baseline, and the arrow shows the baseline data, and the boxes show the differences between our classifier and the baseline. And what is good is that the performance is most of the time comparable to the one we observed in our lab study, which we published at ICSI 2 years ago, which is nice, as this suggested the ideas behind the classifier, so how to pre-process the feature and the signal and the machine learning machinery, then they are transferable from the lab to the field study. However, we evaluated the classifier in 2 settings, and in the leave one subject out setting, we trained the classifier on n-1 participants and test on the old out one, and we repeated this for all participants, and we observed that there is a drop of performance when we enable this setting, meaning that there is a high variability between participants in several biometrics. So this call for further investigation in the direction of individual training of emotion models. And here is the link to the paper if you want to check further details, and I'm happy to take your question. Thank you very much.
Thank you, Nicole. That was nice. And I think that is one could nicely connect that to the previous presentation. Okay, our next presenter is Stefano Sarrioli, and you're presenting about worldwide gender differences in public code contributions.
Yep.
And
Can you see my screen?
yes, we can see your screen.
Great. So, hello everyone. I'm Stefano Zacchiaroli from the Polytechnic Institute from Paris. I'm going to present some joint work with Davide Rossi from the University of Bologna in Italy. So, the general context of this work is gender balance in free and open source software. And it is something which has already been studied at a very large scale in a data set, which is essentially the same we're studying here, to show that although the overall amount of contribution from authors that can be recognized as women is very low on average and also in aggregate, it has been growing steadily for the past 10 to 12 years, reaching for the first time 10% of contributions in 2019. So what we wanted to study in this specific study is whether there are differences around the world. So whether in some specific regions in the world there are more contribution from women than in others, and whether the trends are the same or not across macro world regions. So we studied that across two separate research questions. So the first one, we studied a breakdown by UTC offset, so the time zone essentially where contributors live, because that can be observed in using commits in public version control system. And we wanted to study that also by world region. Then we encountered some interesting data about COVID-19, which I'm also going to briefly report about. So the dataset we used is Software Heritage, which is the largest public archive of essentially version control system data, containing more than 100 millions of public repositories coming from different places. So you have your usual 4Gs like GitHub and GitLab, you have package repositories, you have free software distribution, and so on and so forth. Taken all together, the dataset that we studied contain 160 million projects for more than 2 billion commits, authored by more than 40 million different authors. And we studied a time span of essentially 50 years, from 1970 to 2021. As we are using different version control system, we could focus only on the data which are common among the VCS we are studying. So essentially the data, the signals we can use to detect where authors are from and their gender are timestamp from commits, author names, and author emails. So we use two different ways of detecting essentially the where authors are from. We use either emails, essentially if it is a domain, is a country-specific top-level domain like .fr or .it, we infer that the authors could be from those countries. Or the other information we use is the time zone. Essentially, we look at the time zone as noted in the commit offset. We compare the name of the authors with names that are popular in world regions that are compatible with that time zone, and we use some heuristics based on scores to assign people to a specific macro world regions. For detecting gender, we use Gender Guesser, which is common state-of-the-art tool for the assigning gender to authors, and that's what we apply to the author names as stated in version control system commits. The regions, the geographic regions we used are those shown here. So as you can see, there are very macro regions. For instance, Africa is lumped together. Then we have Central and South America together, North America, Europe, and that's essentially the granularity at which we are doing this study, which is the best one can do when analyzing at this very large scale with the signals we had available. So the key takeaways are that essentially we confirm that worldwide, the general trend of women contribution to the production of publicly available code is more or less the same all over the world. So it has been increasing slowly but stably over the past 12 years, up to until 2019, let's say, with an exception of West Asia. So in West Asia, the trend of contribution of women to public code seems to be either decreasing or in any case, increasing with a much slower trend than in the rest of the dataset we have analyzed. Interestingly, we noticed an effect, a very negative effect of the pandemic on the contribution of women to public code. And here we are focusing on the data for the last 5 years we analyzed in the data set, so up to 2020. And this is the ratio of female contributions per year. So essentially how many active authors there are in a given year that could be recognized as women. And as you can see, there is a significant dip in all regions we have analyzed in 2020. So given the correlation with the pandemic, it is entirely possible that the pandemic has impacted more the ability of women to contribute to public code than the ability of men. as it is being observed in other fields other than essentially computing and IT. So our main takeaway is that the gender gap is shrinking, modulo the negative peak in 2020, but it is still very high, and it is reached only about 10% as a peak in 2019 all over the world. There are little differences among world zones, with the exception of West Asia, and there is an interesting, negative phenomenon in 2020, probably due to the effect of COVID-19 on the ability of women to participate to public code production. And that's it, and I'd be happy to discuss more, and you can see the paper and the accompanying video for more details.
And yes, I wasn't expecting actually this step in gender balance during the pandemic. Okay, thank you very much. So the next speaker is Maria Spikova from Melbourne University, and we haven't been the possibility to try things out before, but I kind of rely on that you will be able to present and
Thank you. Well, I hope everything went well, will go well, because this is the second ICSE session, so I hope everything will be fine. I will now share my screen and put the slides on. Can you see my slides now?
Yes, we can see the slides.
Wonderful, thank you. So my name is Maria Spikova. I'm from MIT University, and today I would like to present our work done together with Mona Alzarani and Dr. Sandra Untenbergen, impact of animated objects on autistic and non-autistic users. Well, animated objects are used quite often in UI, and in some cases they are really a core of UI, but sometimes they are just an addition, which is not really bearing some important context and content. We also know that many autistic users are very sensitive to visual overload in everyday life. And this is potentially also a big part of overall population. So approximately 1% of overall population might be on autism spectrum. And this might make us assume that actually autistic people should be actually in focus of computer interaction studies, because they are potentially more sensitive. However, in reality, we have the opposite. Autistic people are often overlooked in these kind of studies. That's why we aimed to cover exactly this area. First of all, we tried to analyze whether animation has a real impact on user performance, and what type of tasks are especially affected by animation if there are some irrelevant animated images on the screen, because our assumption was that there is an impact for sure, and this impact should be huge. And well, I can spoil that this was also confirmed by the data at the end. But what we also would like to analyze within this study, how does the effect of this irrelevant animation differ within autistic and non-autistic users? Is the impact the same or not? So on this slide, you can see the main results, and I assume that you are now also pretty much distracted from what I actually would like to show you, because you have an animated logo of our university on the same slide. So I will now remove the distractor, and I suppose that it now looks better, correct? So this is also what we assumed that the result will be. If animation is not hugely related to the actual task, it will have an impact, it will distract. It will impact the task duration. The task duration will take longer if we have an animated image on the screen. The task completion rate will also drop. Well, in this case, it was statistically significant. However, it was also only a small drop in completion rate. And it was especially significant within autistic cohort. And the number of errors when task is completed is also higher when we have animated images on the screen. When we analyze the increase in animated conditions, when we looked at the several tasks, we identified that the type of the task is actually a matter. When we need to concentrate more, these might have really bigger impact. For example, reading a paragraph and answering questions about this paragraph might take up to 72% longer. Where identifying an option from drop-down menu or editing an email where the task is small, these will have not so big impact. For example, for solving Sudoku puzzle, I didn't put the data here because when solving Sudoku puzzle, many participants simply stopped solving the puzzle because of animation. We had only one special task, searching for particular information by typing query info in the search box. And this task was the only task was actually done faster with animation, but this was very special case because it was possible to copy paste instead of typing. And then we had a result that many users tried to solve this task as quick as possible just to get away from the annoying image. The overall result was that autistic users had a greater likelihood of not completing tasks with animation. And this was especially the case with Sudoku puzzles. Generally, both cohorts, autistics and autistics, were impacted by animation, and the mean duration of the task was in general longer for animated conditions. However, when we speak about duration of the task, autistic participants were impacted more than non-autistic participants. So mean task duration for autistic participants was 40% longer versus 19% longer for non-autistic participants. With number of errors, we had an opposite situation that, well, in both cases, we had more errors in animated conditions, but the increase in the number of errors was smaller in autistic cohort. But this was also related to the situation that autistic users stopped a number of tasks when there was an animated image there. And this also brings us to what we would like to cover in our future work. We would like to have a larger number of participants in their work, because this was a relatively small project. We had 26 non-autistic participants and 12 autistic, and also we were unable to attract any participants with autism spectrum condition level 2. We had only level 1 in this study, and this is like a lighter version, and we assume that autism spectrum condition level 2 might be more complex situation where the impact is larger. Also, in our cohort, yes, the last point. So some participants in non-autistic cohort didn't have English as their first language, where all autistic had. And this might also mean that we had also lower impact that might be in real life. That's all. Thank you very much.
Thank you. Thank you. So, yes, now we have our last speaker, that is Tobias Lorenz from Germany, or Innsbruck. And he will talk about social science theories and software engineering research and its systematic.
Okay, I will begin sharing my screen and put it in presentation mode. So you can see my screen and hear me well?
Yes, thank you.
Perfect. Thank you, Yvonne. So hello and welcome everybody to the presentation of this paper called Social Science Theories in Software Engineering Research. The authors of this paper are Paul Ralph from Dalhousie University in Canada, Michael Felderer from the University of Innsbruck, and myself also from the University of Innsbruck. So as we only have 5 minutes, let's jump right into the topic. Software engineering is a fairly young field with constantly emerging phenomena, and we find ourselves more and more often concerned with topics that are not purely technical, but rather related to human factors. And for instance, the motivation of software developers, work-life balance of professionals, the economic factors of software projects or strategies for learning come into mind. And at the same time, there's an increasing interest in theory use. There have been, for instance, a number of theory workshops. There have been special sections in journals on theory in software engineering. And that is no surprise because there are many benefits of incorporating theory into research. We are, for instance, able to mature the discipline to organize and preserve knowledge, to explain and predict phenomena, and also to improve the quality of research while reducing the need for trial and error. And given this increasing importance for both theory as well as social factors, we wanted to investigate the use of theories from social science disciplines within software engineering research and to perform a review of existing literature. And to do so, we examined articles from 5 software engineering journals over a course of 13 years by searching for occurrences of theories from a social science discipline. And those discovered theories were then inspected and classified according to several characteristics, including the discipline of origin, where the theory comes from, the theory scope, and so on. And we also sent out a questionnaire to, okay, that jumped a bit too fast. We sent out a questionnaire to authors of these primary studies we identified to ask them about their experience and challenges with applying social theories in software engineering research. And now let's take a look at some of the notable results of our review. We retrieved just short of 6,000 articles total from software engineering journals. And excluding non-research articles, we were left with over 5,500 articles to search for theories. And after searching each article, we were able to find and include 102 primary studies using at least one social science theory. We found a total of 87 unique theories from social science disciplines that were used in these primary studies, which corresponds to less than 2% of articles using a social science theory. It's interesting to note that about 1/3 of the theories we discovered were used in multiple articles, while 2/3 were used in exactly one article. By far the most used theory is the technology acceptance model, which is used in 13 papers, followed by dual coding theory and diffusion of innovations theory. And the authors used theories mainly to inform the study design. We found that many occurrences of theories that are the basis to formulate hypotheses as well as research questions and also to design surveys. The majority of theories come from psychology and management, which includes also information systems and organizational studies, where we found quite a few of the theories. This makes sense as software engineering research is often concerned with the psychological and management topics, especially in context of software engineering projects. And other disciplines we identified were economics, education, communication studies, sociology, philosophy, and also linguistics. Then we also mapped the articles using one or more theories to knowledge areas and found that a lot of them are from the area of professional practice, which makes sense given that social theories are likely to be most helpful in areas related to human aspects. And then I would quickly like to mention responses of authors using social science theories. We asked them about benefits and challenges encountered when applying those theories. And one benefit the authors mentioned quite often was that there is no need to reinvent the wheel. Other disciplines often have concepts in place to explain certain phenomena, especially concerning human factors. They are able to provide the theoretical foundation and guidance for research, and they also provide us with an interdisciplinary perspective by connecting technical as well as human aspects. And while the overall attitude towards theories was very positive, we received a number of challenges. Some authors mentioned that theories often seem too abstract in a discipline that is often guided by practice, such as software engineering. And that often the theories from other disciplines do not fit the emerging questions of today. We also received responses indicating that it takes quite a lot of time to understand theories, especially from social sciences, and that there was quite a bit of uncertainty attached to using theories, that everybody does it differently, and that space for failure when applying theories is desperately needed. And that concludes the presentation, and I would like to thank you a lot for your interest in this topic.
Thank you very much. Yes, that was a rich bouquet, and yeah, I was now kind of. I think now we displayed all the presenters, but Maria is not displayed in the top window. Anyhow, I have a question, and that is going in asking into Dinesh and Stefano's presentations, because I think I was actually quite shocked that the contribution of female programmers to open source communities during the pandemic. And I was wondering whether, Dinesh, your research maybe provides an indication of what could be the explanation for that.
Okay, so I hope I got your question because you were cutting a lot in terms of sound. But so that is something kind of an incidental finding. It was not part of our initial research question, but when looking at the ratio of participation of female authors to on a yearly basis, it really jumped to our eyes that there is a sharp decline, which is in contrast with the trend that has been very stable for almost 15 years now. So we did not have a specific validation for that because we didn't interview people asking why or going after authors to investigate that. But what we found is that in fields other than computer science, there's been several studies showing that the pandemic has disproportionately affected women in their ability to do various kinds of activities, both work-related and non-work-related. So for now, our best guess at an explanation of what is happening here, that is the same phenomenon is also impacting the ability of women to contribute to open source. So this is so essentially it is consistent with findings in other fields, and we think that is a reasonable explanation of what is happening here.
Thank you for that question, Yvonne. I wanted to kind of cite two things because I think it's funny that you asked that about open source. A couple of my co-authors for another paper we're presenting, that Stefano also references in his work with Ayushi Rastogi and others, we were looking at how open source contributors have been evolving over time. Something we did actually, in fact, do some of the mining. We did the mining, and we did a couple surveys with contributors as well to figure out what kind of encourages women. So I linked that in the chat for folks who may be interested. Like the appendix has the details of what respondents were saying. So I'll cover the first study, the one that I presented today. So in the first study, we finding as much because I think it was more of one of those, it wasn't as prevalent as, and as we didn't have as much quantitative evidence to support some of the things we're finding, but we did see a significant alignment with what Stefano was mentioning, that there are other responsibilities and other additional studies, that diary studies that other folks have conducted at MSR, at Microsoft, have also identified something similar. I think it's one of those things where a lot of developers who identify as women or identify as caregivers in their family we're trying to struggle and balance it. And in the early stages of the pandemic, when we conducted our study in March 2020, we saw something similar. However, when we talked to folks, when we did have one-on-one folks, people shared some of the findings. They were like, "Thank you for sharing this, so I can show this to my team," right? So I think it's one of those issues where people in the early stages of the pandemic weren't sure how to be vocal about it, and then it figured out as more research studies that are coming out, they started using them as references. For the other study that I linked in the chat from Ayushi and David Lowe, Arthur Prana, and others, we were looking at, we did see again the study Incline that Stefano mentioned. However, we wanted to also kind of put a unique opportunity to highlight what are the positives that we're seeing, right? So we actually specifically asked people, what do you think will encourage participation? So thinking about awareness, I think there's also a paper at ICSE this year about awareness-based mechanisms to encourage women and to encourage marginalized people in development. So I think there's definitely an opportunity there to kind of think about how to improve, what types of support mechanisms look like when you start focusing on the people in the margins, and how you can amplify some of their experiences, because they're there, they just want the resources to help support them.
I think there could be quite a bit of research also kind of looking to working it from home for people with different backgrounds and different setups. So Maria, how would you kind of like, okay, you looked into animations on the screen. Would your research also apply for other distractions when working? So would distractions during work affect different people differently?
Well, no, this was a project which was focused only on animation. However, I agree it would be really interesting to see what might be also other distractors. But the whole idea of the project started from the point that, well, both investigators of the project are pretty sensitive to the these kind of distractors. But well, I don't identify myself as autistic, but I know that many people who identify themselves as autistic, they say that are extremely distracted by these things. And I wanted to have some real evidence, not anecdotal data, but real data collected systematically to analyze them. And well, to expand this, it would be definitely interesting in many directions. For us, it would be especially interesting to have a larger project with a larger number of participants. Also to cover several levels of autism, because then the results might be also different in terms that the impact might be actually higher. And also we had a situation that number of our non-autistic participants were people with English as foreign language, and all autistic participants had English as their first language. And the tasks were obviously in English. And we are not sure whether these also had some impact, because if we would have like more balanced cohort, it might be then the impact is actually larger than we identified. Also, I have seen a number of questions in the chat. Am I allowed to answer them here? Yeah, Thank you. So regarding the errors, why error rate was less for autistic participants? Well, one reason for this was that a number of autistic participants, they actually stopped doing the task at all under animation conditions. Then obviously this was not counted as error. This was counted as stopped activity. And non-autistic participants, they actually completed the tasks. Then also there was the case that it might be that now increase in the number of errors was related not to the difference autistic or non-autistic, but English first language, English second language. These might have potentially more impact on this number of errors. And this is why I also would like to have a deeper analysis related also to the situation when you do the task in your first language or not. And I think this is the main set of questions. Yes, yes. So the most people were surprised by errors.
I just recognized that these questions because I was in a chat with Julia and I didn't navigate back here. But then there's a number of questions also to Tobias. Maybe you can go through the chat. I think the first one is Lutz that asked for Tobias, and then we have probably also maybe you can answer it and ask your question.
Okay, the sound was really cut off, but I just think you were mentioning the first question: how do researchers trade off theory use when theories do not fit software engineering? Yeah, I believe that you maybe have too high when using theories. They would have to take context into account that to really see whether a theory could be applied depending on the relevant phenomena they are looking at. And just saying, okay, the theory does not fit my research agenda makes it maybe a bit too easy, because you really have to dig deeper into a theory, into the numbers that of theories that come from different social sciences. There's so much available. We even had one response to our survey. Somebody indicated that a software engineering researcher, obviously, that he even decided to do another master's in a social science to understand social science concepts, to let those concepts influence his research, his understanding, the not only the theories, but also the methods from social sciences. So I think that's kind of a brushing off theories when saying, okay, they do not fit my context of research. Yep, exactly. And then let me quickly see at the next question, how theories could be adapted to fit software engineering. And also, that really also depends on the context. I think context is a really important concept here, because those theories are definitely not a one-size-fits-all solution. It really depends on the research, on the phenomenon. And we found quite a bit of theories that were actually adapted to software engineering, and not only adapted, but also extended for research in software engineering. So there were quite a few theories that are software engineering theories that are based on social science theories that we discovered. So that's an interesting aspect as well.
Thank you very much. Do you have, so from your point of view, some comments or questions for the other authors of the session?
Yeah, I would love to. Did any one of you come across social science theories, or don't have to be theories, but concepts from social sciences?
What do you mean? So we've used it in our work, or we've read about them? What do you mean with
Yeah,
encountered
definitely
them?
used, or maybe decided against using it for some reason. Were other disciplines, other theories impactful, or did it also not fit the context?
Well, as far as I'm concerned, social aspects are necessarily involved in some emotion modeling, for example, because there are some emotions that are inherently associated to the personal experience, like I am struggling with comprehending some code, so I'm feeling frustrated. But some other emotion can be related to the relation between peers, for example, to comparing each other and our own performance, for example. So, and also the fact of self-reporting emotion itself, it's necessarily mediated by some social concepts that we hold, some beliefs that we hold about social structure and relationship that we have with others. So this might not probably exactly what we were asking about, but this is kind of related in my view. And so we have also to take into account the fact that people normally act in a social context. So they, even when we are designing study, like in our study, we were using experience sample for self-reported emotion, we should consider that people are acting in a social context, so they might have different perception towards being comfortable or not with self-disclosing emotion, with talking about these topics as they are kind of related to their work. So they might also involve some kind of evaluation and assessment of their own performance. If I don't know, if I'm self-reporting something negative about myself. So in general, I can say that this is kind of related to what I studied. So this is at least my personal experience.
Okay, interesting. Thank you.
Thank
I think,
you.
Lutz, you're raising your hand.
Yeah.
Let-
It's not a theory, but I've recently become very interested in the notion of culture. And I'm currently looking for ways to actually use it in research. So we are using the term all the time, but nobody looks at it closely and tries to operationalize anything about it. And I think if we could do this, it would become a very relevant theoretical lens for lots of SE research.
Isn't that also context in some kind of form, culture?
What do you mean?
Depending on a study, let's say motivation of developers and so on, that the cultural background could be different for and be relevant for different motivations, for instance. Yeah.
The definition of culture that I have come to like the most is culture is a set of community-specific ideas about what is good, true, beautiful, and efficient. And you look for these 4 types of characteristics and how people perceive them and how much value they attribute to them. And I think that makes a lot of difference in lots of cases in software engineering, and it's not necessarily connected very much to national cultures or regional cultures or anything like that.
So it could be company culture, it could be personal values, could be anything.
Yeah, for instance, okay. I think there are cultures connected to some programming languages that might be interesting to understand better, nail down.
Okay. Thank you. We have
Imran
Imran as a last question.
Yes, it's not a question, a comment.
It's comment. Oh, okay.
I'm hearing my echo, so I'm getting confused on that. Anyway, so I've used social theory from social sciences from our work to study developer-centered security behavior, and we've used social identity theory from our from social sciences with social psychologists, and we designed a study to study how the social identity affects developer security behavior to the feelings of responsibility and care for the community they work in. And the theory by itself is very effective. It's a work of 20 years and quite mature. But when we were adapting, we adapted it to study security behavior. We invested a lot of time and energies to design it properly. But sometimes there are some unexpected challenges when you're working with developers that we could not foresee. But we had a rich data, so we could come out with very good analysis of their behavior, security behavior based using this theory. This work is, we've reported this study in Chase this year, which you're most welcome to attend it, in which we have talked about influence of developers' perspectives on their secure coding behavior using this social identity theory. And the challenges we've faced in recruiting developers for multidisciplinary study, that is also published in ROPES this year. So I invite you to attend that as well, because both of these work involve use of theory from social sciences that might be interested to the audience.
Cool. Very interesting. Yeah, we found one instance of social identity theory in our search as well. So that
because
really
unfortunately we could not find the significant results, but the problems were in how we are recruiting the developers. So that's an interesting take. I think that would interest you as well. Thank you.
Very interesting. Cool. Yeah.
Thank you very much. And I am very happy for this interesting and engaged discussion, but I also will have to leave now. So feel free to continue, but in this room, because I need to take care of my next session. Thank you.
Thank you.
Thank you, Yvonne.
Thank you, Yvonne.
Do we have any questions still left open?
I think Maria was going to add a point to a culture comment earlier. Maria,
Yes, this is not really a question. It's really just a comment regarding national culture. So the national culture actually has an impact. We had another project where we analyze impact of national culture on requirements engineering activities. And the result was that actually there is an impact. We didn't look at the programming activities, only on what might be the issues within the requirements elicitation process and everything around it. And we realized that some aspects of the Hofstede model, they really they really help to distinguish what might be especially critical points if we focus on that particular culture.
Thanks
Very
for
interesting.
adding that.
Thank you. So any more questions? I'm answering a couple in the chat already.
I mostly had follow-up questions for Lutz. Is it pronounced Lutz or Lutz?
Lutz.
Lutz, thank you. I was in the session previously where you were asking some really interesting questions as well. I don't know if the presenters are here as well. And I wanted to follow up on some of the breakdown, and maybe this follow up with some of Tobias's questions earlier about who's using social theories. I think oftentimes in our software engineering bubble, we're in a bubble and people forget that people are doing work outside of this outside of this field. And I know that for the authors, many of you also like publish in other venues as well, where you are explicitly have to draw on different social theories, social science theories as well. And maybe the question is also for Tobias. How have you compared some of the social science engineer venues? I know your paper cites TSC and others as well, compared to those that are intersectional by nature, like Chase, which is intentional to be intersectional. SE Motion is one I know Nicole publishes a lot in. And there's a whole bunch of other journals as well that some software developer or software engineering researchers publish in.